Hello guys, so welcome back to my channel. Trust we are doing okay. Today it's the last of the C pointers, arrays and strings, and we are going to be doing justice to everything in this task. You see that we've done one of this, task 1 of this, task 2 and task 3. That is to show you how important this concept is in C programming. Yeah, because it has to do with strings and memory allocation. So it's something you're going to be seeing over and over and over again as you go ahead to program. And one beautiful thing about ALS is that it just prepares you for the life ahead of you as a software engineer, because you're going to be meeting challenges like this in the future, and how best you can tackle them and resolve them will make you a better software engineer. Right now, just like what we've been doing, there is a Google document in the description of this video that contains answers to all the questions, including the main.h file and the putcar file. So if you don't have the time to sit and watch the video to the end, you can simply just go to the Google document and write out your code there. All right. I encourage you to use your hand to write the code so that you understand, or you can get acquainted to how these things are being written. All right. Very important, because it will look very simple, but when you have to write it, you know that it's not as simple as it looks, because once you miss a semicolon, or you miss where a square bracket is supposed to be, or a curly braces, you miss the whole thing. So it's important that you use your hand to write. But if you can stick around, good enough. I'm going to be explaining some of this concept to us, so that we have better understanding of what we are doing, which is the main reason why you are here in the first place, to learn. And if you don't understand this concept at all, maybe this is the first time you're coming across my video, then go back to the introduction to pointers, arrays and strings and watch. And once you watch that, you will better understand what we're doing here. All right. Now, I have already included my putcar.c function file here. I have also included my main.h file, where I've included all the prototypes. So vi main.h. So I have all the prototypes here, including the prototype for putcar.c. And let me just include string.h, just in case there's a need for it, for string.h. So of course, you know that this takes care of the string function of most of the string functions. Yep. So just in case, so that we don't start adding it to the file, once we include it here and we include our main.h to the file, then it's included. Okay. So we have, and then I also added the text file for some of the files work we're going to be doing. So the main.h C files, just to test our work before we push them. And another thing I want to talk to us about is that always make sure that you push your code to GitHub. ALS is not checking your terminal. ALS is checking your GitHub account. So make sure you post your code to GitHub once you are done writing your code, and then make sure you check your code. Either you manually mark done, or use the checker to check your code. Provided your test is correct, Betty is correct, your test is correct, I mean your check is correct with the test file, automatically your code is okay. You can manually check done, or just to be double sure, two-factor, you can then use the checker. But always make sure you click done or use the checker to check your code, and let checker mark you done before you move to the next question. All right. Don't forget to push your code. And another thing I want to tell us, because I have a lot of these questions, you don't need to use a SANDBOX at this stage. SANDBOX is slow and it needs network. When there's a glitch in network, it will affect your code. So you can either use a git bash with SSH or without SSH, or use your Vagrant or Ubuntu to work. It's easier, it's faster, it's simpler. Now, when you're using your Ubuntu to work, you don't need internet. It's when you want to push that you need internet. So you can actually do all your work, and then when you want to push, you use the internet to push to GitHub and check your code. All right. So SANDBOX at this stage is a no-no. It's too slow for you. It's going to slow down your work. So try the best you can to use either your Vagrant, your Ubuntu, or your Git bash to work. Okay. Now let's go to our question. Question 1 or tag 0. Sorry. It says write a function that fills memory with a constant byte. The memsec function fills the first n bytes of the memory area pointed to by s with the constant byte b. Return a pointer to the memory area, and then the standard library provides a similar function, which is memsec function. So if you do man memset, you should be able to see the standard library memset. So this is the memset function, which is from the standard library. So so hash includes string.h and memsec function. It says that the memset function fills the first n byte. This is the n byte of the memory area pointed to by s with a constant byte c. So fills the first n byte. So whatever is the first n byte here, it fills it here. Constant byte c, it fills it here, that is pointed to the memory area. And then he said the memset function returns a pointer to the memory area s. Okay, and then once you are done filling it, return the pointer to the memory area s. So that is for the standard library. And but ALS has also given us our own memsec function, which is underscore memsec. So that is what we are going to use. Let's copy the function for this particular question. Okay. So the name of our file is memset.c. Let's include our header file. Okay. Now let's document Betty. So first, our function name, which is memset. I will just say function name. The next is a parameter s. So I'll just say parameter s. The next is parameter b. I will just say parameter b. You can better describe this, please. Give it a better description. The next is our parameter n, and I will just say parameter n. And the next is our return function, and I will just say s, and then we can end our documentation here. Great. What do we do next? Let's open our curly braces and start writing our code. Now let's declare a variable to use. So I'm going to use a unsigned int. Did I get this right? Unsigned int I. Why is it unsigned? Because it is an integer, but it's not a negative integer. It can never be a negative number. It can only be positive. That's why it's unsigned int. Okay, so here we leave a line for Betty documentation, so Betty doesn't complain. And let's loop through our project. So for I is equals to 0, and I is less than the n byte, of course, because we are looking at the first n byte, and I plus plus. Yep. Okay, let me just try and be nice and guard this. So what are we supposed to do? We're supposed to fill whatever is in the pointer, the n bytes in the pointer, the first n bytes. We're supposed to fill it to b. So whatever is the first n byte, we're supposed to fill it to b. So let's return s. Okay, so now it says that the function fills the first m byte of the memory area pointed to S with a constant byte B. The first m byte pointed to the memory area with the constant byte B. So what does this mean? The first m byte, so if it's, let's say we have 5 m bytes here, it's going to fill the first m byte here, right, with the constant byte B. Now, it's pointed to the memory area. So whatever is in the memory area, which is the m byte in the memory area is going to be filled to B. So that's all that we're asked to do. Simply write a function that fills the memory with a constant byte. And what is the constant byte? The constant byte is the n byte that is pointed to the memory area S. So we'll just fill it to here. So that is X equals to B. And that is all we're asked to do. And then return the pointer to X. So here we can just save and exit. Okay. Let's run Betty to be sure that Betty is fine. Betty 0 memsets.c. Okay, line 12 and 14. Let's fix that. Line 14 seems okay. Let's look at line 12. Okay. Let's look at line 14 again to be sure. Okay. So let's check Betty again. Space provided after that open parentheses, which line 15. Okay. Okay. There's a space before the I. So that is Betty trying to just make us go through. So let's go ahead and copy our compilation line. So let's check our code and see. Okay. This is from when main.h. Okay. So there is something that is wrong with that main.h. Let's go and fix that. So vi to main.h. Okay, yep, double I. So if not defined, if defined, that's correct. So let's run our checker again and see. Okay, and then let's check our code. 0 memsec. So as you can see, it fills the memory area with the constant byte. All right, so if you check your test file, you should have the same result. So that means we are good to go. Let's move to the next question. So the next question is question 1. Question 1 is the memcpy function. It says write a function that copies memory area. So this is just to copy memory area, and we also have a standard library that does that, so you can check the manual for memcpy memcpy and see what it does. The standard library provides a similar function. They say that the memcpy function copies m bytes from memory area source to memory area desk, returns a pointer to desk. So all it does is to copy the m bytes from one memory area to another. Copies m byte from memory area source to memory area desk. Okay, so let's see how we can write this. First, let's write the file name. So vi one memcpy dot c. Okay, so let's include our header file #include main.h, and let's copy the prototype of our function. Okay, now let's document Betty. memcpy. I'll just say function name. The next thing is a parameter dest. I'll just say parameter 1. The next is a parameter src. I'll just say parameter 2. And the next is parameter n. I'll just say parameter 3. And let's write our return. So return pointer to dest. Okay, so let's see how we can write this code. Now, because it's unsigned int, that means our variable is also going to be unsigned. Unsigned int. So let's use I. All right. Unsigned in I. So let's loop for I equals to 0. Equals to 0, and I is less than n, I plus plus. I'm sure that you are really used to this by now. Okay, now let's write our code. So we are copying whatever is index, square brackets, not curly braces, to source src. Copy whatever is indexed to source, and once that is done, return this. Okay, I think this is all we are asked to do. So copy whatever is the memory location of this and take it to src. Let's see if our code will work properly. First, let's check Betty. Let's copy our compilation line. All right, so let's see compiled, and let's check our code. One memset. Okay, so whatever is in dex, copy the same to source. So as you can see, everything in dex has been copied to source. Everything in dex here has been copied to source. That is all we are asked to do in this question. So let's move to the next question, which is question 2. Question 2 is the str_chr function. It says write a function that locates a character in a string. And then there's also a standard, the standard library also provides similar function, which you can also check using the manual. So man str_chr to see what it does. It says that the function returns a pointer to the first occurrence of the character C in the string S, or no if the character is not found. The function returns returns a pointer to the first occurrence of the character C in the string S or null if the character is not found. So if the character is not found, it returns null. If it's found, it returns the function to the first occurrence. The first occurrence of that character, it returns a function to it. So let's see how we can write this code and better understand what they are saying. Okay. So what this is simply saying is that if we have a function, where's my paint? Yep. If we have a function, let's say this function is hello. Now, it's going to check where the first occurrence of this is with another function or with another file. So let's say we have hello and we have hey. All right. So now it's going to check. So let me use this for LLO. So it's going to check L. It will check, is this L? No. It will move. It will check again, is this L? No. Once it sees L, it will pick from here the first occurrence where there is L. It will account for this, and then it won't account for this. So it will pick from where it has the first occurrence of what is checking for, either the M byte, the S byte, or whatever it's checking for. It will pick from where you have that first occurrence. So now it is going to print, instead of printing LO, it's going to print L, L, or something like that. That is what this simply means. It's going to print from wherever it sees the first occurrence of what it's looking for, is where it's going to start printing from. Okay, so that is what this function does. So let's see how we can write our code. So our code, our function name or file name to strchr.c. Let's include our header file main.h, and let's copy our function. Okay, so let's document Betty. strchr function name, like my convention, but please do better with your description. First parameter is s, so I'll just say parameter s. Second parameter is c, so at c I'll just say parameter c, and so return c. Okay, I hope this is cool by Betty. All right, so let's write our function. Let's write our code and see what our code should look like. Now we are asked to return a pointer to the first occurrence of the character C in the string S, or null if the character is not found, or null if the character is not found. So if the character is not found, let's return null. If the character is found, then return the pointer to the first occurrence. Wherever is the first occurrence of that character, return it to us. Okay, so let's write our code. Now we are going to use a while loop so that we're able to give these conditions. So while s is not equal to the terminating null byte. Why s is not equal to the terminating null byte? What should we do? Why s is not equal to the terminating null byte? So let's give the condition. If the pointer s is equal to c, that is, you know what this equal to is, right? It's comparing it. It's checking comparison. It's not assigning it. If this is equal to c, we should return s. So just check through x. If you compare it, if it's equal to c, return s. That is what this function is. If not, then let's give it another condition. Of course, they say if it's not, then it should return what? It should return null. So let's give it a condition for that. So if you compare s to c, if you compare s to c and the occurrence is not found, then it should return null. It should return null. Okay. So now let's look at our condition. Why the pointer to s is not equal to the null byte? Of course, if it's not the last, provided it loops from the first character to the last character, but excluding the null byte. Let's compare. We are comparing x, memory location of s, and c. If x is compared to c, what happens? So it's going to loop through s, pick c, and loop through s. If it's compared and there is an occurrence, that is, a letter in s matches with a letter in c, it should pick the first occurrence to the last occurrence, the last letter, and print it. So even if you have hello and the first letter is let's say O, it should only print O. If the first letter is E, it should print E, L, L, O, right? And exclude H. But if not, if that is not found, then it should return the null value. Okay? So let's I hope this guard will not give us issues, but let's just try and see first. Let's check Betty first. Betty is fine. Let's copy our compilation line. So let's compile our code and see. Oh, I didn't copy that well. Sorry. Let me do that again. Okay. Great. So let's check our code. So as you can see, now if you look at your test file, your main.c from the internet, you see that what is passed there is hello, right? What is passed there is hello. That's the s, the pointer to s is carrying hello. And then when you search for using your x and f, which is declared, you see that it's L that is passed. So searching for L and S, the outcome is going to be, it will pick from L. So it will skip E and H, and then from the first occurrence, which is L, it will print the remaining string of numbers. So that is what this function does. It will just check for the first occurrence and pick from the first occurrence to the last occurrence. So if the number that was passed was E, it's going to print from E, which is the first occurrence, to the last number of the string. That is what this function is all about. Don't forget to git add, git commit, and git push your code, and make sure you use the checker to check your code. Let's go ahead and answer the next question. So the next question says that we should write a function that gets the length of a prefix substring, and then there's also the standard library also provides us with a similar function. It said this returns a number of bytes in the initial segment of S, which consists only of bytes from accept. So it returns the number of bytes. How many bytes are in the initial segment of S, which consists only of the bytes from accept. So it will also compare and check and see, and then it will only pick whatever is in accept that is also in the initial value is what is going to pick, and then it will print the number. For this, it's going to print the number of characters it's able to see. All right, so let's start by writing the file name. So 3 strspn.c. Let's include the header file. Main.h. Now let me copy the prototype of this function. All right, so let's document Betty on this and see how we can write this. So a function name strspn, function name, our first parameter is s, parameter 1, second parameter is accept, parameter 2, and let's just add a return. Characters counted, something like that. Okay, but before we do this, let me just show us an example using the standard function. Let me show us an example of what this is. Let's just save this. We'll come back to this. So let's save this and let's just create a file that we will delete later. So let's call this file test.c, right? Sorry, vi test.c. So let's include the standard library. stdio.h. Okay, so here I'm going to use the main function since we are using the standard library. So I'll use the main function. Okay, now let's write a simple code. I'll just declare some variables here. So this, I will declare this as x, and let me initialize s to be, s to be hello you. No, I don't want hello me, something like that, space. Okay, let's just leave it at that, and then let's declare another character and let's say this is f or y, whatever, equals, let's say this is only, okay, semicolon, place semicolon, and then let's declare an unsigned I don't know why this is always difficult to write. Unsigned. Yep. Unsigned int n. Okay. So let's compare this. So n is equals to the standard function, which is a strspn. And let's pick our parameters, which is s, comma, y. And let's use a printf function to say printf %u or lu for unsigned int. And then let's pass our value n. Okay. So let's run this code and see what is going to return to us. So gcc test.c strspn function, what's it saying? Okay, so let's include a string.h function. Because it's a string, so hash include string.h. So we've not been having errors because we already included the string.h function in our header file. So let's run this again and see, and let's test our file a.out. So you see that it returns 5. Let me cut our file and see. It returns 5. Why did it return 5? Now it will check and see. We have h, here. We have e, here. We have l, here. We have o, here. We don't have m here, and we don't have e here. So if you check, h is 1, e 2, double l is 4, and o is 5. So 1, 2, 3, 4, 5 is what is printed. We don't have this. Let's go back and do something. Okay, let me just clear this. Okay, so let's do something. Vi test.c. Let's include something here, or let's remove this, and let's remove this, and let's include something like I here. All right, so here is going to run and check. We have o, we have o, we have l, we have l, we have e, we have e. There's no I, there's h. So it's going to print how many characters to us? 4 characters. Let's see. So gcc test.c. a dot out. So let's vi and see. Sorry, cut our file and see. Cut test.c. Cut test.c. Okay. So here, okay. So what this has done is that it checks for h and it sees h, and here is a mismatch. I didn't explain this concept. Here is a mismatch. So when there's a mismatch, provided that there's a mismatch, even if you also have the same characters in the string, it will break. It will break. Provided there's a mismatch somewhere, it will break. So if there's a mismatch, it's not going to check, it will just break. So it counted only h and it breaks. So if we then take this I, we take this e across to I, it will count h and e and it will break because there's a mismatch somewhere. Let's do something like that. So vi to test.c, we are learning, this is a new concept, that's why I'm trying to do this so that we just understand this. So here I'm going to say e, then I will add I here. So let's run and see, and then let's run our code. So here you see that it only counted 2 because there's a mismatch after h and e. There's a mismatch before this. So that is what this function is all about. So let's go ahead and let me just remove this. Let's go ahead and or let me leave it. We might still use it. Let's work with what we have. Which file are we supposed to work on? We're supposed to work on 3 vi 3. Great. So let's write our code. Let's write our code. So it's the same thing we are going to do here. All right. Returns a number. They say write a function that gets the length of a prefix substring. Returns the number of bytes in the initial segment of s, which consists only of the n byte from accept. So that's all we are going to do right now. First, let's include our curly braces for our function. Yeah. Okay. Let's declare what we are going to use for our loop. So I'm going to use int I, and I will use int k. So I need 2. So let's leave a space for Betty, and let's loop. So for I is equal to 0, not equal to the terminating null byte, I plus plus. Okay. Okay. So let's give it so this is going to be a nested loop. I'm sure you are familiar with this already. So let's also check for k, because we are looping through the two, the memory and then accept, and then we're going to pick whichever characters are matched between them. So for k is equals to 0, or let's just, rather than going the longer route, let's use a simpler way of doing this and just pass k here, so that k will just run through it at once. And rather than, because here we're already terminating the end of the string, so here k will just run through the string and check. Okay, loop through the string and see there's no, it will stop at where the string stop without, because we are using this to check for this. We're using k, which is accept, to check for x. So k will just check through the string and see, is it there? If it's there, yeah. If it's not there, break. So we don't need to even check for the terminating number, but you can still do that. I don't think it's necessary, but if the checker doesn't allow us to go, then we can check that. So k plus plus. Okay. Okay. So if accept is equal to, so that's the end of the string now, the terminating null byte. So once it check and is equals to the terminating null byte, that is the end of this loop. Return I. Okay. I think this is all we need to do. So let's go ahead and run our code. First, let's check Betty. So 3. Okay, Betty is fine. Let's copy our compilation code. So let's go ahead and compile and work and see, since Betty is okay. Okay, we're missing a semicolon somewhere. Let me just quickly do that. So vi 3. Whoosh, what is this? Code just run into problem. 1 minute. Okay, so that is sorted. So let's this is where we miss the semicolon. Yep. So let's compile again and see, and let's check our code. 3. So as you can see, it printed 5. So if you check your result from the intranet, from your main.c, it should be 5, and that is okay. So we are good to go. So don't forget to add and push to GitHub. Let's see the next question, which is question 4. Question 4 says, write a function that searches a string for any of a set of bytes. Of course, the standard function also does the same. It says the function locates the first occurrence in the string of any of the bytes in the string. Accept. Return a pointer to the byte in S that matches one of the bytes in accept, or no if no such byte is found. So similar to what we did before, here it also searches for searches for any occurrence, the first occurrence that matches the string. Once it searches for it, it prints it. If it doesn't see it, it returns no. Okay, so let's do something. Let's see how we can, maybe we should create a test file and see how we can write something like this for better understanding, right? Let's create a test file for this. So let's use that same test file we used before, and here we are just going to change the function name. Everything should remain the same, but let's just change the function name. Okay, so the function name here is strpbrk. So you can check the man function of this to understand what this exactly will do for you. Okay, so let's run this code and see what this code is going to print out to us. So gcc test.c okay, so we use unsigned as well, so this is supposed to be character. Sorry. This is supposed to be a character, so char, and we can make this a pointer if we like, not necessary, but if we like. And so since it's a character, it's s, so if we don't make this a pointer, then we can just put c here. All right, but we are using s because it has to search the string. So let's go ahead and check. This should be fine now. And let's run our code and see. So it printed hello. It printed hello for us. Let's cut our file. Okay. So this searches for the match. I'm trying to see why. Hold on. Yes, okay, so it's correct. It's correct. So it searches for it. Now let me open a file name. What it does, it says this function locates the first occurrence of the string s, which is the first occurrence of the string s, which is h. All right, and in this case is h, the first occurrence of the string s of any of the bytes in the string accept, returns a pointer to the byte in s that matches one of the bytes in accept. So returns a pointer to the string in s that matches the byte. So once it sees what matches this, it returns it. If it doesn't see it, it will just print out null for you. That is what this function does. So let's clear this and then answer our question. So first, our file name is 4. Okay, so let's copy our prototype. So let's document Betty. Function name, and then our first parameter is s, so parameter 1. Our second parameter is accept, parameter 2, and return if not seen. So let me just say always 0. Okay, so that is it for Betty documentation. Now let's write our code. Great. So we're going to loop through our code. So let's use the while loop. So that's our first condition we are checking for. And let's declare a constant that we will use. And let's set that to be equals to accept. Okay. Great. So we have set that to say, then let's declare another loop here, nested loop. So while a, which I have set to be accept, while a is not equal to the null byte, while a is not equal to the null byte, we're going to say, I'm going to explain this to us. Compare it to the pointer. So remember, the double equals to is comparison, the single equal to is assignment. And here we'll say return whatever is in S and increment to search for more. A++. And if not, if there is no match, return null. Okay. So while the pointer is not equal to the null byte, we declared a constant a and assigned that to be accept. And then we say while accept is not equal to the number, that is provided is the length of the string and it's not equal to the terminating null byte, what should we get? That it should pick the pointer of x equals to a. So it should match the two. Compare a to s and see from our test example that we did, and see if there's any number, the first occurrence that matches it. Once it matches it, then it should print out x. It should print out whatever is in s. But if there's no match at all, it should return 0. If it matches it, then it should check the first character and move again, check the second character, move again. If it doesn't, it should print s. So at each point this run is going to run once, and then this will also run. So this is going to run, the a is going to run into a and run through all the characters in accept and see. If it matches, run the first one and increment to 1. If it matches, it doesn't match, it moves to the second one until to the last one. Once it runs to the last one, what will happen? It will enter the loop again and go back and check for s. Check the letter, the string, the second string in s, and see, match it with a, match it with c, match it with until it gets to t, and then run again, enters the loop and check the second character in s until it checks the last character in s. And once there's no match, leave the loop and then print null. Okay, that is what this is all about. Let's go ahead and save our file. Then let's run Betty on this file. Okay, let's copy our compilation line. Okay, so let's compile our code and see if everything is okay. Oh, not again. We are missing a semicolon somewhere, line 23. Yes. Okay. So let's compile again. That is okay, and let's run our code. Of course, that is correct. So check from your main.c, the intranet, you should have the same result. Make sure to git add, git commit, and git push. Okay, so here we come to the end of today's tutorial. We have all the answers in the description of this video. I really don't want our videos to be too long, so I try the best I can to explain the concept that I think are really necessary to explain, and you know, have the other answers that you can just look at it, look at the answers, go through them, look at the mem function, and you see what all the function, what they do. Of course, I think we've almost exhausted all the functions in string, arrays, and pointers. Thank you for always sticking through to the end. See you again in our next video. Don't forget to subscribe, like, and share, and also give us feedback. God bless you.